Hello, students. How are you today? You're welcome to this class. We're going to be having a review of our Unit 2. The title is Material Properties and Change. That is the topic, Material Properties and Change. And we're going to be looking at what is matter. Matter is anything that has weight and takes up space, or you can define that matter is anything that has mass and takes up space. You're talking about the same thing. You're talking about the same thing. Okay. Now we have three states of matter. We have gas, liquid, and solid. Now you can see the arrow pointing to the gas. This is how the particles are arranged. The particles are free and they move around. The liquid, the particles are also free but not as free as the gas. Then in the case of the solid, the particles are compact together. Okay, so you can see the particle diagram here. Examples of matter, we have gas, we have water here, we have a solid, this is a stone, this is bulgar. All of these are examples of matter. Okay. In fact, I want to tell you everything that you see on the earth right now are matter. Everything on the earth is a matter. It has weight, it occupies space. Changes of states, changes of state here refers to changes of state of matter. Okay. You can see a solid can change to a liquid by a process called melting. A liquid can change to solid like water changing to ice block by a process called freezing. A gas can change to liquid by a process called condensation. A liquid can change to gas by a process called boiling. Then we also have it here. A solid can change to gas by a process called sublimation. And a gas can change to solid by a process called de- deposition. Now, you were not taught sublimation and deposition in the class because it's not in your syllabus, but I just added it here for more information for you as you go to a higher class. Okay, let's look at these melting points. We have ice. The melting point of ice is 0 degrees centigrade. The melting point of glass is 1710 degrees centigrade. The melting point of silver is 962 degrees centigrade. Don't forget about this melting point. Some other substance, compounds, and material have their different melting points, but you just focus on these three. Thermal conductivity. What is thermal conductivity? Thermal conductivity simply means heat conduction. The word thermal means heat. The word thermal means heat. Okay, you can see example here. We have this metal used in building. We have nails. We have frying pot. We have a pressing iron here. We have cooking pot here, and we have a metal spoon here. These are thermal conductors. They can conduct heat. Okay, so if I want to cook, I know which materials to use. If I want to um, um, use a spoon, I know whether this spoon is can conduct heat or not. Okay. Then we also have thermal insulators. Thermal insulators do not conduct heat. They do not allow it to pass through them. That is where we wear this thick jacket during cold season. When you're feeling cold, you wear thick jacket. Why? Because thick jacket do not allow the heat coming from your body to leave your body. It stays within the jacket and your skin, and so you can feel warm. Do you understand that? Okay. Then you have this flower vase. It cannot conduct heat. Then you have this flask. Now inside this flask, are layers of a thermal insulator that do not allow the heat of the water inside to leave the water. So it doesn't allow it to leave the water, to leave the flask. Okay. The same thing for this cooler. The same thing for the towel. They could not allow it. For instance, if I'm cooking and my pot is covered with a metal cover, I can use a towel to remove the cover of the pot that is boiling, because I know that a towel cannot conduct heat. So I can use it to remove it. I'm sure you know what I'm talking about. Okay, so we look at the next one. We also have electrical conductivity. This is talking about electrical conductors. These materials you see here can conduct electricity. Electricity current can pass through these material: nail, wires, copper wires, spanner, screw, plug head here, then this ring, like a boiling ring. Okay, so these are electrical conductors. They can conduct it. They can conduct it. Then we also have electrical insulators. Now, you look at this very carefully. Look at this part, this brown part of the plug is made of plastic, metal, rubber that do not allow electric current to pass through. That's why if I want to hold my socket, my plug, I have to hold it from this side, from this brown side. Then you have the tires. We have here also a wooden structure here. This is a plastic, it doesn't conduct electricity. You have your hand glove. So if I want to do something electrical, I have to wear my hand glove, because with my hand gloves, electric current cannot flow and cannot get to me. Then we also have the tape. You can use this tape to tape this part of the wires. They do not allow electricity to pass through them. Now, if you look at this wire, look at this part, this blue part, this blue part, see, they do not allow electricity current to flow out. That's why they are taped with this plastic part. Okay, don't forget that. All right, next we're going to talk about physical change. Okay, there are different kind of changes that we see. We have physical change, we have chemical change. Now, this is physical change. An example of physical change is when you crush a can. When you crush the can, you know, it's a physical change. You get it? You can actually bring it back again. You can bring the can back. You can straighten the can again. When you melt an ice, you can freeze the melted ice and it will become an ice again. When you boil water, the water leaves as vapor, but you can gather it again. You can condense the water and bring it back again. Mixing sand with water, you can mix sand with water. There's a physical change, but then you can separate the sand from the water again. How do you do that? By boiling the water and the sand. The whole water leaves and the sand will still be remaining. Breaking of glass is a physical change, because you can actually bring the glass back together again and through different kind of process, and then a new glass will be formed again. Dissolving sugar in water is also a physical change, because you can separate the water and the sugar by allowing the water to boil and the sugar will remain in the pot. Shredding of paper is a physical change, because you can actually bring the paper back again through some other kind of mean. You can bring the paper back again. Chopping wood is a physical change. You have chopped the wood, but you can bring it back again through some other kind of process. You can bring the wood back again. Just like wood are used in making, they're used in making papers. Wood are used in making papers, textbooks, and all the things that we use. They are made from wood. I hope you know that. They're missing green and red marbles. When you mix green and red marbles together, there'll be a physical change, but you can separate the green marble from the red marble. Okay. Sublimation of dry ice. Dry ice can sublime. Okay. From a solid to gas, and then it can be brought back again by the process called deposition. By deposition, the the dry ice can come back again. So that is all about physical change. It means that the product you get, the product you get can come back again. It's most of the time physical change are reversible. So they are reversible. That's what I mean by they will come back again. When I say they will come back again, I mean they are reversible. Okay, good. Then we have okay, let's look at this. A reaction where the reactants form products which react together to give the reactant is called a reversible reaction. Look at it. This bulb, this blue bulb plus this purple ball. You can see this arrow. When you see the arrow that goes that point forward and backward, this arrow is a sign of a reversible reaction. Anytime you see an arrow that points forward and backward, it's telling you it can come back again, forward and backward. So these two have reacted together and they form this product. But you see, this product can be further broken down into two and they'll come back and form this. That is a reversible reaction. Now we're going to look at chemical changes or chemical reaction. An example of a chemical reaction is iron rusting. When iron rusts, that is the end. You can't get it back again. When you burn a wood, you get a new product entirely. See, one thing about chemical change is that it is not reversible, it is irreversible. It means that when substance A and B react together, they will form some substance D or substance C. And substance C is a totally different substance, different from A and B. So it cannot be reversed back again to A and B because totally different. They have different property. Their properties have changed. Their mass have changed. So many things have changed. So they can't come back again to the same. So it is irreversible. Metabolism of food, like when you eat food and it digests, the digested food cannot come back again to become the food again. So it's when you cook an egg the same way. When you cook an egg, you can't get the egg back again to where it was before. It have a different structure. The structure of the protein inside it has been affected. So it's a different thing entirely. Baking of cake is the same thing. You can't get the flour back again. If you have baked the cake, you have baked the cake. You can't get a flour back again from a baked cake. Electroplating is also another one. You don't know what electroplating is, but as you grow older in your studying, you understand that. Then we also have rotting banana. When a banana is rotting, you can't get it back again to fresh banana. It's not going to work. Vinegar and baking soda mixture, when you mix the two of them together, they form a different compound entirely. There will be release of gas and all of that. And that is a chemical change. Fireworks, some of you know fireworks, like those things you use during festival or during the national day, and they'll throw it up and to make some sound. Fireworks cannot be gotten back again. Chemical battery, see, they are all chemical change, they cannot be gotten back again. Now let's look at the final one, which is evidence of a chemical change. Now, this is a very important part because a lot of time this comes out in exam. What is a chemical change? How do you know a change is a chemical change? How is a chemical change different from a physical change? This is how you know. Color change. When you see the color of the product change from the color of the reactants, you know that it is a chemical change. When you notice that there's a precipitate, a different precipitate means that you discover a new product entirely with a different color, you know that this is a chemical change. When there is a gas bubbles, like you are reacting the compounds together and then there's a reaction that form a gas bubble, know that a chemical change has taken place. When there's a light, maybe there's a spark like this and there's a light formation, know that a chemical change has taken place. When there's a temperature change, maybe the temperature suddenly increase after you add the two chemicals together, then there is smoke or there is a increase in temperature. The container becomes very, very, very hot. Know that that is a chemical change. Remember also that we said that in a chemical reaction, we have the reactants and we have the products. The reactant are usually on the left and the product are on the right side. Okay, so we have reactants and we have products. Several reactants gives you a product. At least two reactants will give you a product or more products. But it can be two reactants, it can be three reactants, it can be more than that, but it will give you a product or more products. So reactants are found on the left of the equation and the product are found on the right side of the equation. I hope you have learned something today. It's good to have you listen to the class. Take your time and answer all the questions correctly, and you'll get good marks. Okay. Of course, those who answer correctly very, very well will get some good grades on Class Dojo. Okay. Bye for now.